Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Acetophenone, pH, CH3, reacts with NaOH as base and p-tolualdehyde, 4-MEC6H4, ChO, in an aldol condensation. The methyl group of acetophenone is deprotonated to give an enolate, which attacks the aldehyde carbonyl of p-tolualdehyde. After dehydration, H2O, heat, the product is an alpha-beta-unsaturated ketone, chalcone type, E1-phenyl 3,4-methylphenyl, prop 2N1-1, i.e., PHCOCH is equal to CH 4-MEC6H4. The double bond forms between the alpha carbon of acetophenone and the carbon from the aldehyde. The aryl group of the aldehyde, 4-MEC6H4, ends up on the beta carbon, far from the carbonyl. Moving on to the next step. Conjugate 1,4 addition with lithium enolate of cyclohex 2N1-ol. The reagent shown is the lithium enolate of cyclohex 2N1-1 drawn as Oli on the cyclohexene ring. This is equivalent to the lithium enolate of cyclohexanone acting as a nucleophile. In a 1,4 addition, the enolate carbon of cyclohexanone attacks the beta carbon of the chalcone, the carbon bearing the 4-methylphenyl group. After aqueous workup, H2O, the enolate is protonated and the ketone is restored. Moving on to the next step. The Michael addition places the cyclohexanone carbon at the beta position of the enone. The beta carbon of PHCOCH is equal to CH, 4-MEC6H4, bears the 4-MEC6H4 group. After 1,4 addition by the cyclohexanone enolate at this beta carbon, the product is 2CH, 4-MEC6H4, CH2 co-pH, cyclohexane 1-1. That is, cyclohexanone at C2 has a substituent consisting of CH, 4-MEC6H4, CH2C is equal to O, pH. And for the final step, this saturated 1,4 adduct with 4-MEC6H4 on the carbon directly attached to the cyclohexanone ring and PHCO on the terminal end corresponds to option C2,3-OXO, 1,4-methylphenyl, 3-phenylpropyl, cyclohexane 1-1. Why other options fail? A and D show unsaturated, vinylogous conjugated products. These would require no Michael addition or incomplete reaction. The 1,4 addition gives a saturated chain. B has phenyl on the carbon attached to cyclohexanone and 4-MEC6H4 on the carbonyl end. This would require 1,2 addition or reversed regiochemistry, which is not favored. C correctly has 4-MEC6H4 on the carbon alpha to cyclohexanone and PHC is equal to O at the end, consistent with Michael addition at the beta carbon of the chalcone. Therefore, the correct answer is C. Therefore, the correct answer is option C.